Hello students, welcome to JCE Connect series of lectures. So in this particular session, I'll be starting module number 3, that is dynamics of fluid flow. So in earlier module we have been discussed about the discharge measuring devices. So that is module number 4. So this is module number 3, where we are going to discuss about the dynamics of fluid flow. So let us first define about what we mean by dynamics of fluid flow. So before that, you all know what the fluid mechanics means. The fluid mechanics is the branch of physical science that deals with behavior of fluid at rest or in motion. So both the condition in fluid mechanics we usually study as well at rest condition as well as in motion condition. Okay, so again in fluid mechanics there are two branches. The first one is a fluid statics. So in fluid static means what? The fluid is at rest condition. The static means the rest. Okay, so the behavior of fluid when it is at rest condition, the study of that condition what we call as a fluid statics. Second one is the fluid is in motion, that is the study of fluid in motion, and that particular branch is called as a fluid dynamics. So in earlier modules we have seen the fluid statics. So that is a fluid at rest condition we have discussed. So in this particular module we are going to learn about the fluid dynamics. So as I said, the dynamic means the fluid is in motion. The study of fluid in motion, then the behavior of fluid in motion, what all forces cause the motion of the fluid, then that particular branch what we call as a fluid dynamics. So again in fluid dynamics there are two branches. One is a fluid kinematics, another one is a fluid kinetics. So here fluid, since we are studying fluid mechanics, so here we have to bother about only the fluids. So here is the fluid kinematics. As you know, the kind means kinetic energy. Okay, that is a motion. Matics means you will be applying the mathematics for the analysis of fluid motion. Okay, so that is what we call as a kinematics, like kinetics. Okay, here kinetics and this one is a kinematics. So what does it mean, the kinematics? Kinematics means the study of fluid in motion. So as I said, the dynamics means the fluid in motion. The study of fluid in motion, what we call as a fluid dynamics. Again in a fluid dynamics we have two branches. One is a fluid kinematics, another one is a fluid kinetics. But what does it mean, the fluid kinematics? The fluid kinematics means the study of fluid in motion where the pressure forces are not considered. So means the fluid is under motion, but we are not bothering about what causes the motion. Okay, I hope you understood. So here we are not bothering about what causes the motion of fluid. Okay, of course the forces are required for the motion of the fluid body, but we are not bothering about the forces what the causes the motion of the fluid. But here we are bothering about what? Only its displacement, that is consideration of velocity, acceleration, flow rate, nature of flow and flow visualization are taken up under fluid kinematics. So means here the fluid is under motion only, but we are not bothering about what causes the motion. Means we are bothering about the rest condition as well as its motion condition. Okay, so that is that kind of study what we call as a fluid kinematics. Then what fluid kinetic means? So kinetic means here the study of fluid in motion where pressure forces are considered. Means here what causes the motion, means in fluid kinematics we were bothering about its velocity, means its position, its acceleration, then its nature of flow, and these all things we study in fluid kinematics. But in fluid kinematics, so what causes the motion means the forces we are going to study. Okay, so what are the forces acting and or what causes the motion of the fluid? So these things what we study we call as a fluid kinetics. So in this module number 3 we are going to study this one. This is okay, that is study of fluid in motion where pressure forces are considered, means the various forces are to be taken into account for the motion of the fluid. So we'll see which all forces causes the motion of the fluid. So we'll see the later part of this session. So again next is types of fluid flow. So you need to know how many types of fluid flows are there. So here the various classifications are being made here. The first one is a steady and unsteady flow. So this is one classification. Second is a laminar and turbulent flow, uniform and non-uniform flow, then the rotational and irrotational flow, then again 1, 2 and 3 dimensional flow, and compressible and incompressible flow. So but for this particular module you need to know the types of fluid flow, especially what does it mean the steady and unsteady flow, and what does it mean the laminar and turbulent flow, uniform and non-uniform flow. So these all things you need to know. Again one more type is a streamline flow, is nothing but a uniform flow only, or it is can call it as a laminar flow only. So you have to know about these kind of fluid flow. Okay, so then let us try to understand the first classification as a steady and unsteady flow. As the name itself says, steady, unsteady, that is with respect to time, if various properties of the fluids, how they are going to change, or if you are or they may not be changing. Okay, so steady means the flow in which condition at any point, if you take, this is a pipe, sorry, so this is the pipe, suppose the fluid is flowing in this direction. If you take at any section, wherever you take, the flow in which condition at any point do not change with the time is called as a steady flow. Means if you take a pressure or a velocity or a density that doesn't change with respect to time, means at all the points whatever the pressure is at section 1, or the same will be at 2, same will be at 3, means whatever the velocity you have identified as section 1, it will be same at 2, same at 3, same at 4, means it will not change with respect to the time. It is flowing with a constant velocity, constant pressure, constant density, what we call as a steady flow. That's why it is being written as dou P by dou T, that is the change of pressure with respect to time is 0 at any section wherever you take. The change of velocity with respect to time is 0, the change of density with respect to time is 0. It's wherever you take, so it will be a constant everywhere. That is the flow in which condition at any point do not change with time is called as a steady flow. Then what do you mean by unsteady flow? The flow in which conditions at any point change with the time is called as a unsteady flow. Okay, means the whatever the velocity you are identified here, it will not be same at 2, will not be same at 3, it will be keep on changing. That flow what we call as a steady flow. So for a unsteady flow, so if you draw, that is suppose if you are drawing with respect to time the flow condition, if the flow is constant you will get a straight line, if flow is not constant it will be varying like this, it is called as a unsteady flow. The river flow is an unsteady flow. It will not be same. If you take a channel flow in a laboratories, if you take a channel flow, it will be a steady flow. We are maintaining the steady flow, means every point wherever you take, the velocity, the density, the pressure will be same. That particular flow what we call as a steady flow. If any one parameter changing with respect to time, then that particular flow what we call as a unsteady flow. Next, the laminar and turbulent flow. So what does it mean, the laminar and turbulent flow? Okay, so laminar flow means the fluid particles move along a smooth, well defined path or streamlines that are parallel. Thus particles move in a laminas or layers, smoothly gliding over each other. So look at this picture here I am showing. See, these are the fluid particles. See the particles here, they all are moving in a straight line. So they are moving in a well defined path. They never cross each other. So whatever path assigned to them, they are moving on that path only. That particular flow what we call as a laminar flow. There are the fluid particles move along a smooth, well defined path. You can path or streamlines that are parallel. So all the lines are parallel. Look at here. So this is one line, this is second line, third line, fourth, all are parallel to each other. They are not crossing each other. They all are moving in a well defined path, and thus the particles move in a laminas, all are moving in a layers, smoothly gliding over each other. Or you can one more way of defining the laminar flow is the flow in which the adjacent layer do not cross each other. Means these layers, these are called as the laminas or layers, they are not crossing each other, they are moving their own path. Okay, do not cross to each other and move along the well defined path is called as a laminar flow. Example, flow of a blood in a small veins. So this is a very good example for the laminar flow. You can understand here the flow of blood in a small veins. So means there the blood particles will be moving in a well defined path. They will not be rushing, they will not be what we call as a crossing each other, that layers. So that particular flow what we call as a laminar. So you can look at this one more picture here. See, these are the fluid particles. See how the particles are moving. They are moving in their own path. They are not crossing each other. These are called as a layers. See the fluid layers, or they are called as a laminas. So in each layer all the fluid particles, they will be moving and they are following their own path. They are not crossing each other. Okay, this particular flow what we call as a laminar flow. So look at this picture here. So I'll repeat, the flow in which the adjacent layer do not cross to each other and move along the well defined path is called as a laminar flow. I hope you understood this one. Okay. Second, turbulent flow. So turbulent flow, it is a reverse of laminar. The flow in which, so look at here, the flow in which the adjacent layers cross each other and do not move along the well defined path is called as a turbulent flow. So example, the flow through a river. In a river you can see all the fluid particles get mixed, or you can say take as a canal flow, or a smoke from the chimney. If you take, all that particles of the smoke will get mixed up and they will not be moving in a well defined path. So look at this picture here. See, these are the fluid particles all get mixed here. So this is what we call as a turbulent flow. Okay, so means all the fluid particle get mixed up. So this is the flow. So suppose if it is moving in this direction, all will get mixed up like this. Okay, even you could take a tap. If you just open the tap, so here see initially it will be having a laminar flow. So as it moves down, means the gravitational force will be acting, so all get mixed up like this. So this is what we call as a turbulent flow. This is turbulent flow. Okay. So turbulent flow means what? The flow in which the adjacent layers cross each other and do not move along the well-defined path is called as a turbulent flow. Example, flow through a river. River flow, you can see it is very much turbulent in flow. Means all the fluid layers or the layers of the fluid will not be in the same path. They all get mixed up. Okay, even smoke from the chimneys and all, they all represent the turbulent flow. Okay, like this, they all get mixed up. Okay, so this is what we call as a turbulent flow. Again, the one more type of a flow profile. Here both are there, turbulent. This is a laminar and this one is a turbulent. So laminar, just look at this laminar. All the fluid layers are moving in a well-defined path. It's okay. So they all are moving in their own path. They are not even mixing each other. This type of flow, what we call as a laminar flow. So this type of flow we can get only at a low velocity of fluids. So we may get that is given as example the blood flow through a small veins. So this type of flow what we call as a laminar flow. So if again in the same motion, if the velocity of the fluid get increases, what happens? Slightly they are going to change their path or can call it as a change their state of motion. That what we call as a transitional flow. Means transition means what? Changing the state. Means the velocity of the fluid particle is changing. If the velocity get increases, slightly they are turning from laminar to turbulent. The meaning is they are changing from laminar to turbulent. That is that state what we call as a transitional flow state. Okay, transitional flow. Again, still if you increase the velocity of the fluids, so what happen? Completely the laminar get changing into turbulent. Like means they all like mix up with each other. All these layers get mixed up. So they will be moving in a random path, haphazard manner. So this is what we call as a turbulent flow. This is what we call as a flow profile types. The first one is a laminar. They are moving in a systematic manner. They are moving in a well-defined path. So each layer will be having their own path. They will not be mixing each other. And turbulent means so all get mixed up. They will be moving in a haphazard manner. This is what turbulent. And in between the state, whatever we call as a transitional state or transitional flow. So one more type is a uniform and a non-uniform flow. So again it's nothing but that is turbulent and laminar. In laminar itself we have a uniform and a non-uniform flow. Uniform means it is the flow in which conditions of flow remains constant from section to section. Means wherever you take here or here, the condition of a flow will be remains same from section to section. So this is what we call as a uniform flow. Means constant discharge through a constant diameter pipe. So if the pipe diameter is constant throughout the length and the constant discharge through a constant diameter pipe, there we get a uniform flow. Means the velocity with respect to the direction, that is with respect to the length, is 0. Means along the length, if you take wherever you take, the velocity will be remain same. That is what we call as a uniform flow. Okay. Then if suppose if it is varying, then that is called as a non-uniform flow. It is the flow in which condition of flow does not remain constant from section to section. Means it is varying, the flow is varying, it is not same everywhere. At section 1, 2, 3, 4, wherever you take, the flow is changing at every section. That is what we call as a non-uniform flow. Constant discharge through variable diameter. Means the discharge, whatever the Q you are allowed to flow here, same discharge, but it is varying everywhere. So that is what we call as a non-uniform flow. Here the velocity will be changed.